My name is Art Bardage, and I'd like to ask you a question. What if we stopped teaching students to compute on paper? What if they did not have to learn to do this, or practice this, or rapidly solve these? Spreadsheets are today's quantitative business tool. So what if students could use them anytime they wanted to? Yes, even on their Common Core tests. If we are to imagine tomorrow, we have to understand today. And to understand today, we have to look back to yesterday. So I want to take you to the year 1202, yes, 1202, when Leonardo of Pisa reinvented the mathematics used by merchants with this book, Liber Abaci, the Book of Calculation. Leonardo was born in Pisa about the same time as the Leaning Tower of Pisa's foundations were laid, about 1170, when Pisa was a great trading city. As a boy, Leonardo followed his father, who was living in Algeria. He was a public official and trader. And in Algeria, Leonardo was tutored in Arabic arithmetic and Arabic algebra. Both then were seen as academic subjects. They were not used by medieval merchants, either in the Arab countries or in Europe. For those merchants computed in Roman math on an abacus. That was good enough for the Roman Empire, where none of the cities should be allowed to have its own separate coinage or system of weights and measures, for they should all be required to use ours. But not for trade between medieval city-states, each with its own weights, measures, and money. And that required a substantial amount of multiplication and division, and the solving of complex ratio and proportion problems. So Leonardo returned to Pisa after being a merchant himself to write arithmetic necessary to merchants. He based it on Indian numerals and place value, and on Al-Khwarizmi's algorithmic procedures in arithmetic and algebra. They used a new technology, cheap paper. By 1500, Leonardo's algorithm math had spread across Europe and become more and more symbolic, making Roman abacus math obsolete. By the 17th century, Leonardo's table of contents, starting with place value, going to multiplication of whole numbers, addition, subtraction, division, whole numbers by fractions, multiplication that is, and then addition, subtraction, division of whole numbers and fractions of fractions, of course, ratio and proportion, rate, percents of something like percents, mixture problems, and other kinds of problems like that. He also included a chapter on what we would today call the Fibonacci sequence, for Leonardo was nicknamed Fibonacci in the 19th century. Then a chapter on solving linear equations, on solving quadratic and cubic equations, a little geometry. Sounds a lot like the curriculum staircase we all know so well. For it is defined by the level of difficulty of the algorithms, addition being the easiest, subtraction next, multiplication next, and of course long division the most difficult, that today every student must climb. Yet so many fall behind, so many will fail. To understand what we should do about this great problem, and it is a great problem, we must first know what 21st century students need. For in 1979, a new technology reinvented the mathematics of business. Dan Bricklin, a Harvard Business School student, working on case studies, wanted technology to enable him to ask, what if? So he and his friend Bob Frankston invented the spreadsheet. Mitch Capor added graphs and also a database, which put a PC on every business desk with a spreadsheet inside. To enable business people to now ask, what if? Not just what is, but what if? And making Leonardo's math that we are so familiar with obsolete. For spreadsheets are function machines, and functions are considered by many, the most important concept in mathematics. It is the basis, functions are the basis of experimental science and of computer programming. What if we based our mathematics curriculum on spreadsheets and thus on functional thinking? What if we envisioned math education as an elevator instead of a staircase, so that every student can gain head math fluency, mental arithmetic, develop number sense, ask interesting questions like how many of the products in a times table are odd numbers, answer questions that often burn for students like what does X mean? See mathematics, as Lynn Steen described it, the science of patterns. In tables, in graphs, in families of functions. What if students could learn math as a creative experience? Connect patterns, take on challenges, join science and art, and to learn to ask what if? What if we change it to 8 cents? With real-world STEAM data, build simulations, build models for finance, for problem solving. What if we could use Fermi-type problems to instill a passion for statistics, for coding, for quantitative reasoning? These are all spreadsheets. They are just the beginning. These spreadsheets and more are available for free at whatifmath.org. Have a great day.